There's something about raw fabrication that is just so beautiful. The sheen of the metal, the colorful welds, the industrial look that it has, that you can see how it was actually made, put together, and envision what it's going to do for you out on the trail. Nothing like it. But that pales in comparison to the vivid colors that we get with paint. Today on the Groovy Cycle Works channel, we're going to be painting these guys up in a beautiful 3-color pink camouflage. Follow me through the process.
The next step in our process is preparing our substrate to take paint. To do that, we need to take it to the media blaster to give it a mechanical tooth. We want to protect all the areas that we don't want blasted, so that's what I'm putting on now, is a little green tape to protect those areas prior to making our next stop.
Okay, we're done with the exciting part of masking our parts. Now, we need to be clear. The reason I put masking tape and our bolts and these little plastic stoppers in place is not to keep paint from getting to these areas, but to protect the areas from our media blast cabinet, because that's the next stop on our journey. So we're going to the media blast cabinet, which has a combination of aluminum oxide grit and glass bead, to do a 2-step process. The first step is that when blasting, it removes any of the itty-gritty, nasty leftover stuff from the fabrication process, which with our TIG welded products, there is very little to remove, unlike a brazed bicycle. Secondly, the media blast cabinet will give our substrate or our base metal a nice mechanical tooth. So even on the microscopic layer, it's going to have a mechanical tooth that allows our primer layer to adhere to. Our subsequent layers, which are our fabulous colors and our clear coat, chemically bond then to the primer layer. And this is really important. I know it's really frustrating when you're out on the trail and you have to bail on that downhill and your bike lands in a scree field that your paint gets chipped and or scratched. But have you ever noticed that it only chips or scratches down to the primer layer? That's the way it's designed. So any type of sharp impact is made so that the chemically bonded portions, which are our colors and our clear, will break free from the primer, but the primer, which protects the substrate, it protects our base metal, is maintained both because of the chemical bond as well as that mechanical tooth gripping onto the material. That way we don't have a degradation in our base metal through heavy use. So, pretty exciting stuff. It puts a smile on my face. What we're gonna do now is we're gonna head over to the blast cabinet and we're gonna hit this with some of our media, get it all cleaned up, and when we do, the next step will be to blow it off, remove all this masking, then chemically wash it, and put all the masking back on to get ready for paint. Right, what do we got hiding in here? Let's see if I can do this one-handed. Oh yeah, looky there. So, after blasting, we removed all the masking, we washed it in acetone, then we put it in here into the bake box
for about 20 minutes on high to let it all dry off. She's nice and clean and pretty. So we're going to take these right back out here to the table, which has been wiped down. All right, let's go get the next one. Okay, with them all blasted up, blown off with air, cleaned with acetone, and now totally dry, our next thing to do is to get these masked up so that we can get ready to paint. So, unlike the sandblasting where we use lots of green tape, we're not going to do that this time. I've talked in a couple videos about how important fixtures are. A fixture is something to hold a piece while it's being fabricated or processed. It does it consistently, uniformly, and provides accurate, predictable results every time. Same goes for our fixtures for painting. So in here, we have some little fixtures that we made up that actually attach to our cranks and allow us to get them painted up without having to have all kinds of tape. So it does a real nice job of protecting the areas that we want to keep clean while still allowing us to get everything painted up quickly and easily. So we'll get these all put on here real quick. Okay, so what you can see is now we have a cover that goes over the entire spindle. It also gives me a handle from which I can hold it during the time I paint. We've covered up the bolt for the chain wheel as well. Now the last thing we need to do is just get a little something right in there to cover our threads. So we're going to pull out one of our caps and we're going to press that in. So looking from the back side, that'll cover our threads, but leave the drilled out section or machined out section for lighter weight open and available so paint can go in there. For our non-drive side crank arm, we've got, once again, another special fixture. So you can see we have a tricoidal polygon shaped rubber right there with a threaded bolt. So as we push that on there, what's going to happen is it's going to expand and hold it in place for us. So get that on there like that. Oh, I'm going to need a different size. So let's get it on nice and tight by hand first. And you can see that offers us, once again, another handle. Get us a plastic cap to wedge in there and cover up our threaded section. We'll put 2 bolts in to the pinch bolt areas to protect the threads, and we're ready to paint. Are out of the bake box. We've got the first layer of epoxy primer in place. And now what we need to do is, because we've let this bake off and dry, we need to give it a little bit of a mechanical tooth so that our colors will adhere to it. To do that, we're going to throw on a set of gloves first, and then we're going to talk about the medium that we're going to use to actually sand and rough up this paint. So we have a lot of different options. A lot of people will use 600 grit paper or 1200 grit paper, depending on what level of mechanical tooth they want to accomplish. Unfortunately, on a set of cranks like this, where we have a lot of edges, so we have the edges that come around the actual crank boss, we have the edges for the pedal bosses, we have the caps that are welded in place. All of these edges
are very prone to cutting through the primer layer. So when I use paper, which has a fairly rigid edge to it, the probability of cutting through the primer and revealing the substrate is high. So what I like to use is a little bit of this type of material here. This is a 3M Scotch-Brite pad. It's the ultra fine gray pad. What's nice about using this is that it's great for clear coats, it's great for color coats, and in this case, primer as well. Why I like it is because, as you can see, it's very malleable. It can bend around, it has a fairly soft edge, while still giving enough abrasiveness to provide the mechanical tooth that we want. I don't have to worry so much about actually cutting through one of the edges on the piece that I'm working on. So it's a little more user-friendly for me. Really like it because of that aspect. So what we're going to do now is we're going to go over the set of cranks, get them all roughed up so that we can move on to our next step, which is our color coats. With our sanding all done, what we have is a nice even finish. We'll get you in the sunlight there so you can see. And really, we're not looking for a lot of mechanical sanding lines. We want it to be very even, kind of dull, just so we know that we broke the surface tension of the piece that we're working on.
Time for a splash of color. So we're starting off with 3 different pinks. The first one here is going to be our basic base coat with a nice light color. You can kind of see it there on the rim. We'll then shade it a little bit darker with the next color of pink, and then finally finish with the third color of pink, which is going to be this nice dark color right here. Once again, another DBC base coat. All right, so let's get our cup and start mixing things up. So straight out of the can, you can see our base coat's pretty thick. So we need to thin that down so that we can actually spray it well. So what we're going to use is a little bit of this stuff right here. This is Reducer. Reducer is formulated so that it works best as far as its evaporative qualities based on the temperature. So it's about 65 degrees here in the shop, and we're going to be using this DT 860, which is made for 60 degree temperatures. How much do we add? Well, I usually start off with about a 1-to-1 ratio. We had 3 spoonfuls of base coat. We'll throw in 3 spoonfuls of reducer and get this mixed up. And what I'm looking for really is how it clings to my stainless spoon here. So when I take this off and I look at it, I want it to run off there fairly well, but see how it still has some good shading there while it's a little bit lighter around the edges? That's about the viscosity that I'm looking for. So once again, we'll let it run off. Got good coverage, just a little bit of lightening up around the top of that spoon. That lets me know that it's going to spray nice and thin. With that all set, we're going to put it into our gun. Today what we're using is a DeVilbiss touch-up gun. Got a nice little cup here. Tight little fan pattern, easily adjustable, great for bikes. Really love this gun. Really sad that they don't make it anymore, but I do have 3 of them, so I'm good to go for a little while. All right, I'll see you in a After 15 minutes in the bake box, our paint is nice and dry, and we can move to the next step, which is going to be applying our first layer of masking. What I've got here is some vinyl mask, and you can see I've drawn this up in Adobe Illustrator to make the general shapes that I wanted. Then I cut it here in this Graph Tech plotter. Then it comes out on this sheet, and I remove all the extra, and we're going to apply all this right here to our crank arms. The idea is that we want to lay these pieces on wherever we want to retain the light pink color. That way, as we spray on the next layer, we'll overlay more masking, retaining the intermediate color, and then finally put on our final color above that. As I begin laying the pieces, I just want to ensure that they are flat, all the edges are pressed down uniformly, and if I go around any bends in the piece, that I'm working them down so they're flush and lay without an open edge. Back in the paint booth, we're showing you adding the next couple of layers. As you can see, we have the final pink layer on here. You can visually see all the masking that lays beneath it. Everything is even, flat, and is holding its edge well. After a quick 10-minute flash off in the bake box, the paint can be handled. I'm starting to remove the masking, starting with the uppermost pieces and working my way back down to the light pink base. I will lay my blade flat on the masking, slowly draw it back until the tip drops over the edge, and then place a little bit of firm pressure forward to lift it up. If you angle downward at all, it's going to cut into the paint below and leave a mark. Take your time, be careful, and enjoy watching the project unveil itself. As we finish taking off the final few pieces, I look with a critical eye to ensure that I haven't missed anything, and enjoy the pile of refuse we've left behind.
Whew, okay, we are done with all of our color coats. What we have now is a multi-colored camouflage hot rod crank arm. To achieve this, you watched me layer on a base color of a light pink, which was that guy right there. And then we built subsequent layers using different colors and more masking until we got to our final layer of the darker pink, which is the predominant color for the entire crank. The caveat to doing this is that with each subsequent layer, we're building height or depth from the top down to the substrate. And as we pull away that masking, it's going to leave a palpable texture between all of our little masking camouflaged areas. What we need to do now is move on to a clear coat. And the point of our clear coat is going to be to level this off and give it a nice glossy, smooth finish. Our clear is going to be made up of 3 parts. We have our base clear, we have a hardener catalyst, and we have a reducer, which makes it more sprayable for us. So it's probably going to take about 3 different coats. And between each coat, we're going to let it cure, then sand it off, and then apply the next. And that's what's going to give us that glass-like texture when we're all done. So if you're ready, I'm ready. Let's head over to the paint booth, and we'll start adding some clear to these cranks. Our first layer of clear came out really nice, even, glossy, and it's starting to level out some of the paint work. Now it's time to break that down a bit. We're going to use the same gray 3M Scotch-Brite pad that we talked about because it conforms well to the edges and won't cut through, which is really important now that we're at this stage because, good golly, the last thing we want is to break through and then have an underlying color show up through the edge. That would just be horrible, and then we'd have to airbrush it and fix it. What a mess. So, I'm going to use the 3M Scotch-Brite pad, and we're going to start just breaking this down a little bit. I've cleaned my hands with a little bit of cleaner reducer to get all the oils off. That way I don't transfer anything to the base coats. And the clear that we're busting down, that way it'll be nice and clean when we put on our next layer of clear coat. So here we go. We'll just start taking this and we're gonna just start giving it a little bit of a scrub. And what you can see is I'm putting a fair bit of pressure on it, enough that I'm compressing the pad, and we should be changing that glossy layer to something that looks a little bit more dull. So as I rotate it in the light, you can see glossy, where I've scrubbed, kind of dull. And we're just gonna break that down, give it a little bit of mechanical tooth, and that way when we're going to be ready to put on the next coat of clear, it'll help continue to fill in those depth differences and make it nice and smooth. So let's go to the time lapse and get this done. I just wanted to show you, even as careful as I was, if you look right there on the very tip of that cap, we cut through just a little bit. So I'm gonna have the opportunity to dab just a little bit of that pink on there. We'll correct it, and then once we flow over the new clear coat, you'll never know that happened.
Back in the paint booth, it's time to lay down a little clear. Now, I typically mix my clear with a little more reducer than normal. And what that does is it creates a higher gloss, it lays much nicer, but it can also create runs that are difficult to catch up with. So when I'm spraying these cranks, you can see me working on the ends that are hard to access first. I'm trying to get down towards the tricoatal polygon receiver as well as the pedal bushing before I spray the entire crank arm. What that does is it allows me to get those problem areas that have a lot of curves, a lot of creases where excess paint can build up, get those flowed out first before I do the pedal body and blend everything together. I keep moving fairly fast because I want to ensure that the clear is laying down, and when I have the whole crank arm done, I'm looking over it very carefully. I'm looking to see that I have even coverage, it's smooth, it's glossy, and if I see any hint of shadow or speckling, which would indicate some dry spray, I want to make sure that I hit that now with my gun so that it can blend it in. I'm going to do this for both crank arms, and then the process begins, which is fairly intensive. Because I'm spraying my clear so hot, meaning that I have a lot of reducer and it's very apt to running, I need to make sure that I keep these things moving while I wait for that activator hardener to begin to firm up the clear so it doesn't sag or run. So as I'm spraying, I'm constantly keeping the crank arm moving. As I take it out and I place it to start curing and drying, I need to make sure I keep rotating it. So in this case, I've got the crank arms and I'm putting them in two vices. For the first 5 minutes, I'm flipping them from a vertical to 180 degrees position about every 60 seconds. For the next 5 minutes after that, I'm doing it every minute and a half. The next 5 minutes after that, I'm doing it every 2 minutes. And I continue that for about half an hour, elongating my time. That way, I'm allowing gravity to fight those sags for me. So when I have a fully cured piece, it's going to be uniform, smooth, with no additional clear coat pooling, sagging, or dripping in any areas. Works out really well for me. Been very happy with that as part of my process.
I've finished up the paint on our hot rod cranks. So we put on a total of 3 coats of clear. You can see that this is straight right out of the bake box. So this is no sanding or polishing or anything like that. But we have a really smooth, beautiful finish, nice gloss. The areas that were masked, like the tricoatal polygon receiver and the spindle, came out looking perfect. The next step is that I need to prep those areas for coating with ceramic Cerakote. That way it'll provide corrosion resistance and smooth operation for a lot of years to come. Cerakote is a suspended ceramic with an activated catalyst or hardener that gets mixed up together just like you would standard paint. It's really important to have our base metal immaculately clean, which we already do. And typically, I'll put a fine tooth on it with the blaster to give it greater mechanical adhesion. But in this case, we're not going to, because I'm not going to get sand and media all over our new paint. This particular material is applied with an HLVP gun, so just like liquid paint. And it goes on really quick. Then it is baked for approximately 2 hours, right around 200, 250 degrees is what I like to do it at. And then it'll give us a nice impervious finish for the steel spindle. And just like that, through the magic of video, 2 hours have elapsed and we are done baking our Cerakote. So I'm gonna pull this off here and grab this and take a look and see what we got. So here's our finished crank arm. Ooh, it's warm. Now you can see we are devoid of all of our masking. Simply because after about 15 minutes of baking, the Cerakote is set enough that you can handle it. So I took the crank out, took the masking off, simply because if the curing of the paint had not completed, I didn't want any of the tape leaving any lines on our finished crank arm. So once this cools off, we'll get it on the table and we'll show you the final product.
Ooh, I'm really happy with how this came out. Cerakote looks nice, complements the pink really well. Only thing we have left to do is get these babies assembled. So let's grab some wrenches, grab the 32 tooth chain ring, and get this done.
We've reached the end of the process. Our cranks are done. You just watched me assemble the final parts, where we put on the dedicated 32 tooth chain ring. All of the hardware and fasteners are put in with thread lock. On our non-drive side, our fasteners get a little bit of grease because we want them to be able to move more freely. So there you have it, the complete process of painting up a set of steel hot rod cranks. I hope you've enjoyed it as much as I've enjoyed showing you. It's been a pleasure, and perhaps someday we can do a build together and a set of these can adorn your new bicycle. Thanks for stopping in all.